Okay. So finally we will have the MESI. So before we go to the question 5.7, I want to review the MESI. Uh, the only thing different is that we have an exclusive state, right? The exclusive. Exclusive means, if you remember, uh, the E state, only one processor and memory, has the copy, has the same data as memory. So share, what is share means? More than one processor has the same data as memory, right? So this is really important. So that is what the exclusive and share means. Share, that means at least two people having the same data. The exclusive means only one people have the data as the memory. And another important thing is the exclusive change into a modified state do not need to send invalid, right? It's really makes sense, right? Only you have the data, so you don't need to tell others to say, oh, you shouldn't, you need to be invalid. Because only myself have the data. I don't need to tell others to do anything related to my data, right? So this is really important things. The exclusive change into a modified do not need to send invalid. Okay. So yeah, actually it just makes this few changes. Oh, another is important thing is yes, I can uh, answer what answer remix in S state, right? It's really important. It's the difference between the MSI. It can answer in the S state, so we can make a summary. The MESI answer. Who can answer? Read miss, right? Who can answer? Firstly, memory can answer, right? And then the modified state can answer, right? With the write back. And then the shared state can answer. That's by it's defined. And the four, the exclusive can answer, right? The share and exclusive actually means nearly the same thing, but uh, they are both can share data here. So compared to MSI, who can answer? Who can answer? Answer what remiss or bus read? Uh, Only the memory and a modified state with the write back. Only these two. Right? That is the difference. That is the difference. And yeah, so that is what you need to know. And as for our question 5.7, we said okay, we get a two implementations in figure. Actually, that's the question 5.2. Compute the total cycles and also use the MESI. This is what we provided, right? And the figure, I mean, two implementations actually are these two guys. That is what we did before, just a 5.2 question. So what you need to show me is that like MSI implementation 1 and implementation 2 and MESI implementation 1 implementation 2. Four things for one part, like part A, right? That is what I want to see. Uh, well, maybe this question makes you confused, but yeah, I just want you to test the difference between the MSI and MESI. Actually, is the share state. Can it share or answer the read miss from the bus between these two kind of protocols? So, okay, let's go. Let's go. What's the first set of the actions? We have C1 want to read AC10, AC10, C3 want to read AC10, and C0 also read AC10. So yeah, that is the question. And let me get the original graph here, picture. Okay, maybe I will put it here. Okay, so like firstly, C1 want to read AC10. Did it have AC10? No, it did not. Any others have AC10? Yes. C0 line 2 have the AC10. And it's a modified state. You need to write back, right? You need to write back. Don't forget that you are modifying. If you are modified, you will need to write back to change into other state. You need to write back. If you are in a modified state, right? I am originally in a modified state, so C0 line 2 need to write back, and then it will get, actually I want to say its answer the C1, right miss, right? It's a read miss. Remember, it's a modified state, so it can answer for both MSI and MESI, right? So here it just fine. So how many it takes? It takes 10 for the write back, and 40 for the implementation one, get it from the cache, or 130 from the implementation 2. Okay, so here they are the same for both MSI and MESI. Action 1 finished. And the second, C3 want to read AC10. Okay, I could not say it's finished. So what's the result of it, of the first action? The C0L2 will be a share state, share state with the address AC10 and also the data 0030, and also the C1 also has the same data, so it's a share state AC10 0030, and also memory have the updated data, that is 0030. So that is the result for the first action. Okay, and it takes maybe 50 or 140 cycles for 2 implementations. Yeah, and then we will go to the next. Next is the C3 want to read AC10. So initially C3 do not have it, but we can see the C0 and C1 have it, have the AC10 already after our first action. So here goes the difference. For MSI, it will get the data only from the memory or the modified state. But since these two guys are both in a shared state, so it will get it from memory. Get the AC10 from memory, right? It's a read miss. Get the AC10 from memory, so that takes us 100 cycle. So how about the MESI? MESI, it can get the data from the from cache. Actually, I mean the shared state or memory. So you can tell me that if I want to get it from the shared state or from the cache, it will take us 40, because the share do not need to write back, right? 40 or 130. And if I get from the memory, it will get 100. So here comes the difference, right? You can tell me two kinds of the situation, and I also shows you two kinds of the result in the solutions, but I hope you can think about it by yourself. So yeah, here is the difference from the second stage or the second action. And for the third one, the C0 want to read AC10. Want to read AC10? Do we have it around? Yes, we have it now. Oh, sorry, I forgot to update the result. The result is actually just the C3. Okay, I have the share state also same as the AC10 with the data with all these three guys, they are the same now. So yeah, we have 4 people, 3 people and 1 memory have the same data for the AC10. Okay, and finally we want C0 to read AC10. Do we have AC10? Yes, we have it. So it's a read hit. Read hit do not generate any stores, so it is 0. So totally it will be, you can see, here, let me use another pen. So it would be 50 or 140 for the first action, and 100 for the MESI in the second action, or 40 or 130 for the MESI, and or 100 for the MESI in another, right? We'll read from the memory or read from the share state. So yeah, these are different kinds of the situation you want to know, and also the finally we'll have 0 stores for the read hit. This is the part A or part 1, and then we have another part is the C1 want to read AC to 0, and the C3 want to read AC to 0, and the C0 want to read AC to 0. Okay, after our initialize, let me split these 2 parts. Okay, after the initialization, we can see when C1 want to read AC to 0, it do not have, but we see that the C3 has the AC to 0. So here also comes the difference. The let's say MSI, it will get it from memory. You get from memory, so it takes 100. But MESI, you can get it from memory or from C3, right? From memory, you also take 100, but from C3, you will take 40 or 130. It do not need to write back. It do not need to write back. It just a share change to share. Actually, yeah, share change to share. It do not need to write back. So here comes the difference for the first action, and then the C3 want to read AC3 to 0. Yes, it has. So it's a read hit. Read hit generate 0 stores, and the C0 want to read AC to 0. Okay, so C0 also, we will see you can get it from MSI or MESI. If it is MSI, you can only get it from memory, right? Because others do not have the modified state. You get it from memory, takes us 100. If it is from MESI, it can get it from memory or from the what we have now. We have C1 and C3 all in a shared state. So yeah, for memory, you take 100. If you goes from the cache, you take 40 or 130. So yeah, that is how the situation goes. Okay, so yeah, that is totally how the MESI works. Just want you to know that the MESI can get the data from memory, from a modified state, from a shared state, and also from the exclusive state. But MSI only get data from the memory and the modified state. Those are the difference. And one more thing, outside of the homework, I want to say is about the true false, the coherence misses. If you remember the questions, well, that's from the textbook or from the slides. Okay, so initially, both two processors have the same cache line, both in a shared state, and one cache line has 2 words, Z1 and Z2. So this line is in a shared state. So first action is that P1 want to write Z1. P1 want to read Z1. What is the coherent miss? Is it hit or true missing or the false miss? So what is the true and false? The true is that you are modify shared state, or you are want to let me see, read line which invalidated by by modify from other, and also it modify the same word, and the false means you are like read, or maybe I would say yes, read invalid line which was modified by other and different word, right? So you can see the difference here. For the false is the different word, for the true is for the modify the same word. So we can get a example here, right? So initially they are both share, and I'll change the share into a modify. What is it? It's a true, right? The modify, it modify a share state. So it's a true. And then the P2 want to read Z2. P2 want to read Z2. So initially the P2 is invalid. It want to read, so it will change into a share. So is it is a true or false? It definitely is a miss, right? So it's a true or false? As we remember, here we're modifying Z1, and here we want to read a Z2. These are what are different, right? They are different, so it's a false. So this action is a false missing. False sharing misses. Okay, so yeah, and it's also the nearly the same thing. Right. So for the third action, the P1 want to write Z1, but previously we are share state. We want to share and change into a modify. We want to exclusive the cache line and send invalid, right? So the P2 will be the invalid, and here will be a coherent missing, right? Because previously we are modify, we are M state, and then we change it to a share. And who caused this share? That is P2. P2 is want to read the Z2, but here I want to modify the Z1. These two guys are different, so it's also a false. It's also a false missing. False missing. Okay, and then we'll go to the fourth action. 1, 2, 3, 4, 5. The fourth is also the P2 want to modify the Z2, and so Z2 is different from Z1, and also the state is invalid, and right. I want to modify it. Actually, it's a bus RDX read X. So yeah, it's also a false missing. And finally P1 want to read Z2. So like it was invalid, yes, but it was read a line which is invalid by modify, and also the modify is modifying the same word, right? The Z2 was modified by the P2, and then which caused the P1 into an invalid. And now I want to read the Z2. That is the same word, so it's a true miss. Okay, so it's a true sharing miss. Yeah, that is how this works. So maybe the a little bit hard to understand is this guy. Why it works? That is because it changes state. It changes states by others. by others, that is P2. P2 change it from a modified state into a shared state, and it change it, and also it the P2 fetch the Z2 instead of Z1. They are different words. So yeah, here is a fourth sharing misses.